Okay, today we are talking about the Geogebra project. Some people are going to refer to it as the graphing project. And this is an example of one of the students in the past that did one that's very doable. It's not like a super straight A plus kind of project. It's not bad, but I'll tell you some things that they could have done that would have made it better. One thing would be if it had color, and we can do that with the Geogebra app that we're going to be using. And another thing that would have made this a little better, this is a fine point, but if this, which is supposed to maybe match up, I don't know, actually maybe they wanted it to match up with the hat instead of with the head. So it looks kind of like, to me, like this strand of hair right here is not matching. I would have had it like touch start right there and go down, but maybe they wanted it to be like hair underneath the hat. So actually, maybe I'm being too critical on that. So what do you think this part is right there? It's a square root. Very good. I'll show you. It's this part right here. You see how it's a backwards square root? It's a square root that got flipped left, right. All right. So you see how they have two square roots here? They have an absolute value right here. That's one absolute value. They need one more. Do they have another one somewhere? The eyebrows, the unibrow. Okay, so there's two absolute values. They needed to have two circles. And you can have stretched circles if you want, like these eyeballs. So they actually had four circles. It's okay. You can have more than two. Oh, you're right. The big face is actually another one. Good point. Some people ask, can you actually just have straight lines? You can have just a straight line if you want to. The simplest of all is y equals x, and that would be like this. Here's an xy chart, or an xy axis. That would be a straight line, y equals x. Remember, you can limit all these functions with this certain tool I'm going to show you so that you can make the line not go forever, because a normal line would go forever. We can limit it and say, I only want the line to be between 0 and 5, and it'll limit it for you that way. So there's a lot of playing around with this before you figure it all out, but you have to have the following 5 shapes in your graph. You have to have a circle. You have to have an absolute value. Actually, sorry, 2 of each of these. So there's a total of 10. There's 5 shapes. You need 2 of each. That makes 10. Absolute value, the parabola, the square root. Actually, it doesn't look like that. It looks like this, kind of the ramp shape, square root. And those are very versatile, by the way. Like, you need to connect like this spot to that spot. You can always get a square root to work. It's just a matter of maybe you had to make it, see, this is stretched up a lot. Maybe you had to make it flip this way and stretch it. Square roots can do almost anything. And the last one is the half circle. So what is a half circle? It's just you take a regular equation like this. And you solve it. Okay, if I solve this for what do I want to solve it for? Come on. When you put it in a calculator, you got to put in y. Good. So you got to solve it for y. So just a quick reminder on that. To solve one of these puppies, y squared equals 4 minus x squared. I'm starting to solve my circle here. Now I'm going to go square root, and then I have absolute value of y. Why is that important? Because I need 2 answers. Why do I need 2 answers? Because when this is done, it's got to make a circle, right? And the first part of the circle is going to look like this. And do you get that the second part of the circle is exactly like that, except it's flipped? So the second part of the circle will be that part. I know that's not a perfect circle, but your top half and your bottom half are an exact flip of each other. It's just an upside down flip. That's why the 2 answers for this are then y equals square root of 4 minus x squared. You always just copy exactly what you have without the absolute values. And then the other equation is identical with the exception of one little thing. What is the one little thing? A negative right there. So there's an example of how to solve your circle equation to get a half circle equation. Okay, this is important because when you're done, you're going to get graded on 3 things. Number 1 is your picture, which has the 10 functions in it. Number 2 is, can you do what I just showed you? Can you prove to me you know how to solve an equation for y, like I just showed you? And then the third thing is, can you prove to me you can show me where 2 equations intersect. Like if I said I have this equation and I have this other equation, let me say y equals here, and I have this other equation, that's actually kind of like that was the half circle thing. Okay, so I've got this equation, the top half of a circle, then I want to intersect with this equation. How do you get two things to intersect? You want to graph both of them and see where they're equal to each other. Yes, where they cross. So you want to set them equal to each other. To get if this y right here is equal to that y right there, then they are actually equal to each other. And therefore, I can just set this equation equal to that equation and solve it. How do you solve it? You can either take your graphing calculator and graph them and see where they cross, or you can actually ask Wolfram Alpha, which is the super powerful website that's like Google except for math. And Wolfram Alpha, if you just type that into the Wolfram Alpha thing, it'll graph it for you and tell you the solution. That tells you where those two lines touch. Why do you care about where those two lines touched? Do you remember back in this project that, like, for instance, this little green line I'm drawing here had to perfectly touch that line. It's really hard to tell where things touch like that unless you set up two equations like that, set them equal, and your calculator will say, okay, well then you want them to touch at, x equals 2 or whatever this was right here. It'll tell you where to do it so that they will touch. All right, I know I just told you a ton of information all at the same time. What you need to be starting to think about is, for tomorrow, you want a picture. I'm going to give you a piece of graph paper, and you're going to start like brainstorming tonight. Okay, I think I want to make a car, and I'm going to have the square root that goes like this. And then I'm going to have a front tire, which is going to be a circle, and I'm going to have it go like this. And then I'm going to have another square root that's going to like be the bottom side of the car. So maybe I'll make it a flipped square root. See what I did there? An upside down square root that's been flipped up down and then moved a little bit. And then maybe I want another part of my car to be another square root for the steering, or for like the bubble where the people sit, And maybe I should even let this one go further. So then this upper area is for where the person sits. And maybe I'll have a circle up in here where I have the person. And just keep it in mind, it's all got to be in terms of square roots, circles. What have I used yet? Absolute values. And by the way, a cheating way to use a half circle, and is totally legal, we'll allow it. You can do this half the circle and that half the circle for the back tire or whatever. I guess this has got a weird placement for that back tire, but anyway. Okay, so you can put your half circles on top of each other like that and make a circle out of them if you want. If you feel like it's kind of destroying your picture to have this stupid half circle in there. Maybe you want the half circle to be like the moon up in the sky, up here and shining down, You can make these different colors too. Maybe you want absolute value to be like the body of this guy in the car. Maybe not. That doesn't look too cool. But anyway, you have to figure out, upside down parabola would be good for the body maybe. So maybe a upside down parabola for the person in the car. Maybe this thing is going too long. So maybe, do you get how, since I can limit it, I can cut it off earlier? Maybe I don't want that to go as far like that. And then maybe on the back side, I want to have a square root that's stretched upwards like that to kind of be the back side of my car. All right, anyway, you have to get an idea of what you want your picture to be. It could be a pastoral scene with a donkey grazing in a field and there's a mountain in the background. It could be a car like I just did. It could be, maybe it's just a face, but it can't just be like a smiley face, okay? I'm not going to give you any good grade for drawing me a smiley face, okay? That's pretty bad. So you should be thinking big. I've had some pretty amazing ones. I want to show you a couple examples of other ones that have been done in the past. Let me clear the ink here. This was what it looks like with color, which definitely helps, doesn't it? and you can color each of your lines in this program that we have. You're going to be doing this all on your iPad. You can sketch it on paper, but the iPad is going to be the thing that like actually makes the equations go in the right spots. This is a pretty good one. Michelin Man. And in case you've never seen it before, he's like supposed to be made of tires. But anyway, Michelin Tire Company. So anyway, that's enough examples for you. If you, I guess I can show you the one more, and this is a very simple one that I would not have been giving a straight A to, but it's okay. It's not terrible. Got some bubbles coming up from a fish. All right, so, but do you notice it's got all the equations right here? The main things you get graded on are, did you have all 10 things you're supposed to have? Do you have, therefore, all the 10 pictures you're supposed to have? 5 things, 2 of each. And you could have other stuff. Let's say you want to include a square root that goes, no wait, no, what's that, x cubed. Let's say you wanted to have an x cubed going up here. I don't know exactly where you would have fit it into this picture, but here's a backwards x cubed. I've had some people do some kind of cool stuff with crossing those over each other. Like here's an x cubed, and then here's another x cubed, and then if you make them just right, they can look like stars like up in the sky or whatever. Anyway, and then there's another function that you guys know that is not required, but do you remember one more function you learned? 1 over x. 1 over x, good. It looks like this. And that can be used, again, I've seen that used as stars up in the sky. That's a pretty decent thing for that. Or maybe you put that inside a tire on your car because it looks kind of like a cool, like spoked wheel kind of thing. Anyway, that's where your creativity comes in. And your part of your grade on this is for creativity. All right, now, the next part, I'm warning you, is going to be a painful part because you got to get used to this program. And it's not super friendly, but to be honest, a lot of times things that are capable of doing really complicated work are a little complicated. I mean, like CAD, for instance, computer assisted design, it can take you 2 years to learn how to CAD draw well because you can make really cool, complicated things with it. If you could learn it in 2 minutes, there'd be like little children designing houses with it. That's why engineers get paid big bucks to do CAD drawings because it's not easy to use the program. Well, the program we're using today is similar in that respect in that it's not going to take you 2 years, but it might take you at least an hour to understand how this program works. Okay, now hopefully, given you understand, it's because it can make really complex things, you need to stay with me as I'm explaining how to do it. I'm going to pair you with somebody right now that you're going to work with for the rest of this hour, and hopefully you guys are going to want to work together on this project. Everybody, to clarify, has to have their own project, but what if she figures out how the lips are going to work, and you're going to figure out how the hair is going to work, and you could put them together? Absolutely, you guys can work together to make this thing, but in the end, everybody needs everything on their own iPad. What I don't want is for the smart kid to go do all the work and the other lazy kid to get credit for it. That's not fair, okay? All right, so right now I'm going to pause for a second and see if I can get you paired up with somebody and get the program called Geogebra open on your iPad. Okay, so assuming for a moment that you have got your project saved, at least sorry, you've got logged in. It looks something like this. You can see up in the upper right-hand corner, I got my little, looks like a French avatar guy. Anyway, I don't know what yours will look like, but it'll be able to tell you're logged in. And it'll offer you these 6 options. We are choosing the algebra option. Considering this is higher algebra, that seems logical, doesn't it? Okay, so touch the algebra option. And for those of you that are behind, I apologize. You'll just have to get your friend to help you get through these next couple steps. They're not super hard. Okay, once I get in here, this is our palette. This is the area where we're going to do our drawing. All we have to do now is type in a bunch of really smart functions on the left-hand side, and you'd have a drawing. But that's the only thing left. You really just need to put in a bunch of functions. So let's just learn how to put in a simple function to start with. I'm going to try to get an absolute value, a V shape, you know, and I want it to only be a V shape between here and here. So I kind of want to make an ice cream cone sort of looking thing. So I want it to be a V shape. It won't let me draw on there. I guess you just have to imagine. Oh, there it is. Yay, it worked. I want a V shape that is like that. Now, do you get that that is an absolute value that's moved 3 to the right? But how do you cut it off? How do you make it only go between like here and here? How do I do that? The domain. Very good. I got to limit the domain. Nope. Limiting the range does not work. I know you might think so, and I get it. You're saying if I could put a boundary underneath and above, that would work awesome. It just can't be done. There's no option for it on the iPad or anywhere else, actually. If you do there is a version of this that some of you guys are going to say, can I just use my PC for this? Yeah, you can do your PC. I can't do it here, but you can do it at home. Okay. And then when you save this to the cloud, you can work on the same project at home or on your iPad. And the iPad's going to be a little clunky for this because they didn't spend that much money on their app, apparently, or I don't know. Maybe it's much more complicated than I realized, but their app is not as good as the Geogebra program is on a computer. Okay, so if you're getting really bogged down with stuff, open it at home on a computer. You just got to download this little thing called Geogebra through Chrome. Okay, if you use the Chrome browser, you can get the Geogebra plug-in deal, and it'll look just like this. You can pull your project out of the cloud, and you can operate it there. All right, so I need a V like this. So how am I going to get that? Well, everybody, how many of you are on this screen now? Am I up to almost everybody? I'm on almost everybody. Okay, good. So we need to get that V shape, and we need to limit it. So to be able to do that, we have to type in the word function first. So everybody touch the ABC button in the lower left-hand corner. It pulls up the keyboard. And then I'm going to type in F-U-N. Keep on wanting to touch the smartboard, but that doesn't work. F-U-N. Notice the word function starts with fun. C-T-I-O-N. Now you need parentheses. You have to do exactly what I tell you. Do you get computers are not smart enough to know what you meant? They'll only do exactly what you told it to. Function, now I have to have a front parentheses. If you hit the little number key in the lower left, it'll bring up the option for parentheses, and they are down low right above the number key there on the left-hand side. Parentheses. Notice 2 parentheses popped up. How many of you are at that point where it says function 2 parentheses? Okay, good. Then we now need to type in that absolute value, except we wanted to move it 3 to the right. So how do we do absolute value? Do you see the key? It's on my screen. Do you see it? Absolute value of x. It's lower leftish sort of area. Absolute value of x. And now inside there, I want to type in x minus 3. X minus 3. Wait, there's more. Get this far, and let me help you get the domain in there. Because if you just try to graph it right now, it will not work. It needs to know from where to where. Let's say that I wanted mine to only graph between 2 and 4. What we're doing right now is, again, putting a couple lines like this saying, I only want you to graph this between here and here. Otherwise, do you get the absolute value would go forever if we don't limit it? It's going to go like this over the whole thing forever. The picture won't look very cool if you don't limit these. All right, so let me get out of there. Correct. Circles self-limit, so they're really easy. All right, so back to, we've got this part in. Now, one of the things, you can touch on your iPad screen to try to move a little to the right, but you can just use the right arrow. Look at the lower right. See those arrows there? Those are very handy for moving the cursor around. I have to get outside of the absolute value, but yet inside of the parentheses. I need to be right there. See where the little thing is blinking? Between the absolute value and the parentheses? I have to be right there. And now I say comma. The comma key is kind of by the 0 down there. Comma between 2 and 4. So we go 2, comma, 4. So it's your function, comma 2, comma 4. Now one more thing. This is an important thing too. When you try to resize your drawings, that's one of the things about the app that's really bad. I don't understand it, but when you try to like drag, zoom in on your drawing or zoom out on your drawing, make the drawing size be different, it sometimes takes as much as 2 minutes to adjust the screen to be back to like to be done with that adjust. So bottom line is you don't want to do that very much at all. So I would do this and I would only do it once. Do you see that bar that runs up and down right here? You can drag that to the right a little bit because we got lots of room over here. See what I mean? That we don't really need. And that'll give us some more room from our functions over here. We make this wider. So if you touch and drag that bar to the right now, you haven't done enough on your iPad yet to have it be like super freaked out. Once you've done like 10 equations, it literally takes 2 minutes every time you want to try to tweak your screen. So you might want to drag it over. I'm going to touch and drag this bar over a little bit right now while it's still happy because there's no functions in there. Just a little bit so I can see that whole function. And then from now on, your goal is to never try to resize the picture again. It's awesome to be able to zoom in and zoom out. I'm telling you, you're going to wait 2 minutes for it to adjust. You can be just going crazy. So try never to resize the window after this. All right, last thing I need to do is to just get my keyboard back up and hit the Enter key. And if I did it right, there should be a little picture there. Now, if yours isn't there, consult with your group members and see what's wrong with your equation, because something went wrong if you don't have your V-shape right there. I will pause for a moment while you try to figure that out. Okay, I had a question about the paper I'm handing out. You are encouraged to use color and stuff on the iPad. No, we don't want you to just do this on paper. On paper is a great way to start the project, but you do need to fight through the process of learning how to put this in on the iPad. Now, if you've, of course, got something official from the school that says that you don't have to, then I can make it work on paper. If you have a written thing from your parents you're not allowed to or whatever, we'll make it work. But the iPad actually, honestly, draws them much more crisp and cool than you could ever do on paper. And especially with the dragging it around option, that obviously, it'll help you in a lot of ways. So once you get used to it, the iPad will make it better. It's just it takes a while to get used to. All right. That's all I have for you for the project. Save.